Hi, welcome back. And today we have a very simple math puzzle. It's about finding the missing number. You have to check the arrangement of numbers, try to find out the connection, the link between the numbers, and find out which number best fits here, depending on the relationship that the other numbers have with each other. Okay, think about it, and later we will get back to this puzzle. And we will work on chapter 3, graphs and functions. The first objective will be to graph linear functions. Let's check here this example. To graph gx equals to x plus 1 and compare with the graph of fx equals to x. Then I have the table here. Let's fill out this table. For x equals 0, we're going to have f of x equals 0, right? And for x equals 1, f of x equals 2. For x equals 2, f of x equals 2 times 2, 4. Now let's find g of x. For x equals 0, g of 0 equals 2 times 0, 0 plus 1, 1. For x equals 1, 2 times 1, 2 plus 1, 3. And for x equals 2, 2 times 2, 4 plus 1, 5. I'm plotting the points in the graph first for f of x. That's represented in blue. 0, 0, 0, 0, 1, x equals 1, 2, and x equals 2 and 4. I have 3 points here. Let's connect the dots. Here it is. Now I'm going to represent the other one, the other graph, g of x, in red. Okay, this is going to be red. 0 and 1, so x equals 0, 1 here. X equals 1, g of x equals 3. And x equals 2, g of x equals 5. The line is going to be, they're going to be parallel lines, correct? Parallel lines. This is g of x, and the blue one is f of x. The y values for g of x are obtained by adding 1 to each y value of f of x. The graph is the same, but is shifted upwards. That means when we add 1 unit to the function, we shift the graph. It's like the blue, the red one is like the blue, shifted 1 unit upwards. That's the effect of adding 1 unit to the function. Next objective. Let's graph linear functions using intercepts. First, let's identify the intercepts. Check this graph here. We have the graph of the equation y equals 4x minus 8. And the y-intercept is going to be the point where the graph intercepts the y-axis. So let's find the point here where the graph intercepts the y-axis. And right here, this is the point, the intersection of this blue, this graph of 4x minus 8 with the y-axis. And this is the y-intersect. And so and then we can write down, we can represent y-intercept is going to be equals 0, x equals 0, right? Y equals negative 8. The other one, the other point that we are interested in is the x-intercept, is where the graph intersects the x-axis, which is this one here. This is going to be the x-intercept, and we can write down here the x-intercept equals x equals 2, y equals 0. That's how we look at the graph and we find the y-intercept and the x-intercept. Y-intercept, x-intercept. Okay? Next thing, notice that the y-intercept of the graph of gx equals 4x minus 8 is 0 and negative 8. X equals 0, y equals negative 8. In general, a linear function is written in the form f of x equals mx plus b, where b is the y-intercept. That means b, if we have the function here, we can easily identify the y-intercept, which is going to be b. b equals y-intercept equals negative 8 in this example here. On any time you find a function like this, a linear function written in this form, you can identify the y-intercept as b. Examples here. Find the y-intercept of the graph of each equation. So this is b. b is 3.5, right? 3.6, I mean. That means the y-intercept is x equals 0, y equals 3.6. The next question here, b. Now y equals negative 5x minus 1 over 3. Negative 1 over 3 is b. b equals negative 1 over 3. The y-intercept is equals 0, negative 1 over 3. Finding x and y intercepts, you have to let y equals 0 or f of x equals 0 to find the x-intercept, and you have to let x equals 0 and so for y to find the y-intercept. Examples here. Find and plot the the graph using the intercepts, and we have the equation. The equation of this graph is 4 equals x minus 3y. We make to find let's find first the y-intercept. So we make what? X equals 0. If x equals 0, 4 equals 0 minus 3y. And after we apply addition property, multiplication property, and we simplify this, we're going to find that y equals negative 4 over 3. Right? So this is going to be the y-intercept. X equals 0, y equals negative 4 over 3. Now find the x-intercept. Now we're going to do the other way around. We make y equals 0, apply, plug in here, 4 equals x minus 0. That means x equals 4. The x-intercept is going to be x equals 4, y equals 0. Usually to graph an equation, to graph a linear equation, we can have at least 3 points, just to make sure that everything is right. It's possible to find a line with 2 points, but we're going to work with 3 points. So make x, for example, we can do here is make x equals 1, then you're going to find the third point. Plug in into the equation 4 equals 1 minus 3y, and then you will have, after you do addition property, multiplication property, you're going to have y equals negative 1. Let me fix this. And going back here to our graph, to the rectangular coordinate system, we have the y-intercept, the first one that we found is going to be x equals 0, y equals negative 4 over 3, right? X-intercept is going to be y equals 4, x equals 0, right? And if we make x equals 1, we made here x equals 1, we found y equals negative 1. X equals 1, another point, x equals 1, y equals negative 1. Go to the graph, find the points. Y-intercept is going to be on the y-axis. Negative 4 over 3 is going to be here 1 and 1/3, right? Kind of here, negative 4 over 3. Now trying to find the other points. The other intercept is the x-intercept, and I think it's going to be here 1, 2, 3, 4, right? 4 and 0 right here. So we have now 2 points. And another point that we have here is x equals 1, y equals negative 1. Negative 1 is here. The third point is this one. Check this, we have 3 points. We can write down, we can represent, can draw the graph. Let's choose a color by connecting the dots, connecting the points. This is going to be our graph. Great. Moving to the next example, graph 2x equals y. And this is a very interesting situation, because we will have, if we try to make x equals 0, you will find y equals 0, and the other way around is going to be the same thing. If you try to make y equals 0, you're going to find x equals 0. That means the y-intercept and the x-intercept, they are both in the same point. Notice that anytime x equals 0, y equals 0 is a point of a graph, then it is an x-intercept and a y-intercept. It is the only point that lies on both axes. And we are trying to graph this, the equation 2x equals y. And moving here, let's write down. We are trying to graph 2x equals y. We know that 0 and x equals 0, y equals 0 is one of the points. Now I have to guess different points. Let's say if x equals 1, plug in here x equals 1, we're going to have y equals 2. And if you have, if you guess x equals 2, you're going to have y equals 2 times 2, 4. Now I have 3 points. Now I can plot the graph. Y equals 1, x equals 2, another point here. And x equals 2, y equals 4. Another point right Now connect the dots and you will find the graph of these equations. All right. And right here is going to be what? Y-intercept and x-intercept, both in the same place, in the same position. Objective number 3, graphing vertical and horizontal lines. Now let's find another situation how to graph the equation y equals 3. To find the graph of y equals 3, we're gonna do the same thing. We're gonna think about y equals 0 times x plus 3, right? Because no matter the value of x, if the coefficient of x equals 0, that means it doesn't matter. You can make x equals 1, you can make x equals 1, you're gonna have y equals 3. You can make x equals 5, y keeps being 3. You can make, let's say, x equals anything, -5, -6. Again, x equals 3. No matter what the value of x, y will always be equals 3. Right? So we can graph here this equation y equals 3, which is going to be a horizontal line. The y-intercept is going to be on y equals 3, right? And we're not going to have here any x-intercept. It's going to be parallel to the x-axis. A summary of vertical and horizontal lines. The graph of x equals c, where c is a real number, is going to be a vertical line with x-intercept x equals c, y equals 0, and horizontal line. The graph of y equals c, where c is a real number, is a horizontal line with y-intercept equals x equals 0 and y equals c. That's it, a summary, and this is also the last slide of the section 3.3. Now we're back to our puzzle. What do you think is the right answer for this puzzle? Think about the connection, the relationship between the numbers, and if you think about the relationship on these numbers here, for instance, you have 3 and 4 and 12 here in the middle, you're going to say 12 have 3 and 4 as factors, right? Means 3 times 4 is 12. The same thing here, 4 and times 5 is going to be 20. And the same thing here, 5 times 5 is 25. If we follow this pattern, we can think that the best number, the number that fits better here, is going to be 15, right? 15 is the number that best fits this puzzle, this arrangement. And the answer here is going to be 15. All right, thank you for watching this video. And again, see you next section.